Hi everyone, as promised before, we're going to develop a more natural measuring unit for angles. Recall that the one that we saw before is using degrees, which is quite arbitrary because we say one full rotation equals 360 degrees and then we proceed with that to get 0, 90 degrees, 180, 45, all of these to mean fractions of the circle. So just as we did it with triangles before, we are now going to consider circle. And recall that it's natural to consider circle because in our definition or our understanding of what an angle is, we talk about rotation. And the simplest object that comes to mind when you think of rotation is a circle. Okay. Right. So we take two circles, concentric circles, meaning they have the same center, and we draw a line. Mark these points A, B, C, and D. Now, even though the lengths AC, now this is not a straight line length, it's a curved length, but we can still measure it. For example, let's say using a thread from point A to B and then measuring the length of the thread. And BD is different. This angle at the center, theta, is the same for two circles of differing sizes. And just as in the case of triangle, there is no direct relation between the lengths, right, as we understand them now, but the ratio AC over OC and BD over OD is going to be the same. Now in this case, AC and BD are lengths of arc, or they are distances covered on the circle, while OC and OD are what is called the radius of the circle. So in one full rotation, the angle is going to equal the arc length if I go around the circle once, divided by the radius. But when you make a full rotation, the length is nothing but the circle's circumference, which is given by 2 pi times r. So one full rotation would be 2 pi r over r, which is 2 pi. And the unit we use for this is called radian. So that's the more natural way of measuring angle. We say that going around the circle one time, the angle equals the ratio of the length covered, which is 2 pi r, divided by the radius, which gives me 2 pi radian. Now this definition, which is called radian, it's obviously tied intrinsically to the properties of a circle. So what does an angle of 1 radian mean? 1 radian means that the ratio of the distance you covered on the circle equals the radius, which means an angle of 1 radian happens if you start at this point and you walk on the circle and you stop when you've covered a distance r on the circle. So that's not a straight line distance but a curved distance. So when the arc length equals the radius of the circle, the ratio becomes r over r, which is 1, and that would be 1 radian. So if you take any circle, 2 pi is all of the full circle. 2 pi is approximately 6.28, which means half is going to be pi and a quarter is going to be pi over 2. Right? Pi is roughly 3.14. So if you make 1 radian, 2 radian, and 3 radian puts you almost at horizontal, but not quite. And then you have 4, 5, 6, and a little change, 6.28 radians. So there's about 6.28 radians in one full rotation. Now since we have these two systems of measuring the same thing, we need to know how to go from one to the other. Right, so one full rotation in degrees is 360 and in radian is 2 pi radians. And they need to mean the same thing, which means 2 pi radian is 360 and you divide by 2 pi to get 1 radian is 180 over pi degrees. Similarly, if you solve for the degree part, 360 degree equals 2 pi radian, then 1 degree equals pi over 180 radian. Let's look at some examples. Convert to radian, 30 degrees. So we know 1 degree is pi over 180. So 30 degrees is going to be 30 times pi over 180, which is pi over 6 radian. Similarly, 150 degrees would be 150 times pi over 180, you cancel out the 10, divide both numerator and denominator by 3, and you get 5 pi over 6. And you can go ahead and try for 45 and 270 in the same manner. Similarly, converting to degrees, pi over 4 radian would mean it is 180 over pi times pi over 4. The pi cancels, 4 goes into 180 45 times to get 45 degrees. Now, because pi is just a number, so the radian can be measured in purely numbers. For example, 10 radian would just be 10 times 180 over pi, which is 1800 over pi degrees. And now if you think about it, that's going to be roughly 600 something, which makes sense because around 6 radians, right? That 6.28 radians is one circle. So 10 radians mean you've gone around the circle once and you're going around it again, which means it has to be more than 360, which makes sense because 1800 divided by 3 point something would be slightly less than 600. So it would be more than 360 degrees. Now, a consequence of this definition is that we can get a relation between the radius and the arc length. Now, let's say you're traveling on the circle and you cover a distance theta, which is measured in radians. That's important, not degrees. Then, by definition, this angle theta is your distance over radius. And then when you cross multiply, you get that the arc length is given by r times theta. Let's look at an example. Find the length of the arc of a circle with radius 10 meters that subtends a central angle of 30 degrees. Central angle just means that this angle is given to you to be 30 degrees. Now this is not in radians, so I'm going to first convert it into radians by multiplying it by pi over 180. That becomes pi over 6 radians. Then I use S equals r theta, 10 times pi over 6, that's 5 pi over 3 meters, which you can use your calculator for now you can leave this as it is, or you can just plug this into your calculator to find the actual value. An alternate question that can be asked is to find the central angle. Yeah? So in this case you're given radius and angle and you're finding S. And in the second problem, you're given that the radius is 4 meter and you're given this length is 6 meters and you're asked to find theta. So again, theta by definition is going to be the ratio of the distance over radius, which is 3 over 2, which is 1.5. But the important thing here is the radian. Yeah? The unit is radian and not degrees. Here's an application. Historically, there's a Greek mathematician called Eratosthenes. He measured Earth's radius, like a long time back, around between 276 195 BC, and he basically used this definition of angles and radiuses. What he did was he noticed that on a certain day the sun shone directly down a steep well in Sian. And at the same time, in another place called Alexandria, 500 miles north, the rays of the sun shone at an angle of 7.2 degrees to the zenith. The two places on the same meridian, and used this to find the Earth's radius. So what's happening here? First, the Earth, we can approximate it by a sphere as the equator. When it says it's on the same meridian, it means that you're on the same arc here. So let's say it's on this arc. So here is the first place, and here is the second place. So what's happening is that the sun ray is straight here, but the sun rays are not straight here. They're at an angle of 7.2 degrees. If this is the center, then this angle is 7.2 degrees, and you know that this distance, the actual distance between the two places is 500 miles. Now this distance is on the surface of Earth. It's actual physical distance. So it's the curved distance. Now 7.2 degrees is 7.2 times pi over 180 radians. This is going to be your theta. And your S is 500 miles. So using S equals R theta, R is S divided by theta. So you are able to find that this is 500 divided by 7.2 pi over 180, which is again a fraction of a fraction. So 500 divided by 7.2 pi over 180, which simplifies to 500 times 180 over 7.2 pi. Again, you can plug this into a calculator to find the value. Approximately this is going to be about 22, and you divide, and just remember that the units are going to be miles because the distance between San and Alexandria was measured in miles. So very simple application which gives you a rather important measure like Earth's radius. Like that's not something you can take a tape measure and really actually measure. Okay, that's going to be where I stopped the first video. Next video we're going to talk a little bit more about